Hello everyone, Mike Silverman here. In this video, I'll show you how you can make a modular character in the Bevy game engine so that your characters can have swappable items, weapons, clothing, and things like that. Here we have an example character where there's actually four parts. We have the head, we have the torso, we have the legs, and we also have a weapon. And these are all from different models which come from the Quaternius modular characters asset packs. We have the modular woman pack where we're using the sci-fi torso, the witch legs, and we have the modular men pack where we put the helmet on them. And there's also another pack for weapons that we're also using. And you can see there's that helmet and these are the different parts. And they're actually all working with the animation correctly. So this was pretty difficult for me to figure out, and that's why I'm making this video, because hopefully I can save people some time on this subject. It actually took me about 2 weeks of focused research pretty much every day to figure out this. So I'm pretty happy that I got it working, and I just want to share this with all of you who want to achieve the same thing. I got the idea for this from reading this article from Unreal Engine where they explain different ways of creating modular characters. And I found that Unreal Engine had some good explanations on the different ways of doing this. And well, I was able to figure out using the master pose component method. And it may not be the exact implementation that they did, but this is how I got the spark of the idea. And basically what we are doing is we are taking the bones that are inside our character, because an animated character has a skeleton and made out of different bones. And those bones deform the mesh of the different parts of the character. So you can see here, if I kind of rotate that, you can see their shoulders moving a bit. Maybe I could zoom in better for that. But yeah, you can see that the vertices of this mesh are getting changed based on the rotation of these bones. And what I do is basically I export the entire skeleton. Sorry, I've forgot the blender controls because the camera controls are different on in Bevy. I export the entire skeleton with all the animations, and then I export the different parts with only the bones that are needed, and then I attach each bone, or do what's called parent it. I make each bone a child of the corresponding bone in the skeleton within Bevy, and then they follow the motions of these bones, which causes them to correctly deform the individual parts because they're just following the animation. And that is kind of the broad overview. We will get into the details of this, but let me just say that this is a proof of concept and it's not going to be like in-depth character creation customization tutorial, but I will show you how to get to this point, and I think with that, you will understand the fundamentals of the idea and be able to expand it to work in your games. So with that being said, we are going to get into the code, and this is going to be split up into different chapters in case you aren't interested in the boilerplate or certain sections. You can just skip ahead to certain parts of it, so feel free for that. But I will show this project kind of from the ground up, building it completely from scratch in Bevy. So let's get into it. All right, so here we are in the Cargo.toml file for our project, and it is pretty basic. We only have a few dependencies. For Bevy, we are using the dynamic linking feature so that we can compile faster, and we also have the Bevy Pan Orbit camera, and that is going to be version 16 because since the last video we have upgraded to Bevy 13, so that is the compatible version for this package. We are also using something called Bevy Mod Billboard, which has not released on crates.io a compatible version for version 13 of Bevy, but if you do this, you can get the package directly from Git or the crate, and you just put in the GitHub address here, and that will give you the Bevy mod billboard crate, which allows you to put little text hovering over things in a 3D world, which we are going to use to label all the different bones and look at them in Bevy so we can examine them and know where each bone is, and just to visualize exactly what's going on will help us learn the uh, about what we're doing. So we also want to use the Bevy Asset Loader crate, which is a way to reduce boilerplate when loading different assets. I did not use that in my last video, so this is I found very useful for loading assets, helps you save some time and code space in the brain. So let us press onward to look at, oh, well, I first should say we have the assets folder in the top level where we're going to put our GLTF files and also a font file so we can draw that text that we were talking about earlier. And in the source, we have the main file, which I have set up a little bit in advance. Most of this I am going to code along, but I didn't want to code along this part because it's kind of very basic and it's very similar to the last video. So we have a clear color, which is going to clear the screen with this color, and that'll be kind of our background color in every frame. And we also have this ambient light. In Bevy 13, I found that you have to change the brightness to a different number. Back in the other video, it was like a 0.1 or something, and it was fine. Now I have to set it to 1000 to get a good brightness. We are using the default plugins. We are using the camera plugin, which is a plugin that I made, which I'll show you. And for our external dependencies, we're using the pan orbit camera, which gives us control over the camera, and we're using the billboard plugin, which lets us draw text in the 3D environment. We also have these two commented out, which we are going to code ourselves later. But first, let's just glance at the camera plugin so you know what's going on here. This is basically exactly the same as in the last video, but we set up a camera 3D bundle and we pointed at some location that makes sense for us. And we also add the pan orbit camera struct here because that is what allows us to use the pan orbit camera crate to control the camera. And you can see the values I put here. And if you put similar values, you should be good. This is actually not supposed to be there. That was from leftover when I was experimenting with something else. So don't worry about the main camera thing. We have deleted that. So that was a mistake. Can delete that as well. So yeah, we have the camera set up and we are pretty much good to go on that. But the next thing we would have to do is load our assets. But before we load our assets, we have to customize our assets for this modular method that we are doing. So with that being said, we're going to head into Blender and see how we can do that after, of course, downloading our assets. So you're going to want to head over to quaternius.com, and in the search bar, we're going to search for Modular, and you should find the Ultimate Modular Women Pack, the Ultimate Modular Men Pack, and I believe there is weapons as well. We can get to the weapons later though. So for now, let us download one of these modular women characters. So we'll click on that. We're going to go to download. We're going to continue to the download. And then we want to go to individual characters, blends, and then we will download the sci-fi blend, and we will download the witch blend. But if you want to download different ones because you like the looks better, that is totally fine and it will still work. So let's see if we downloaded that. Looks like it's downloading, and we are good to go. Then you're going to go to your downloads folder or wherever you downloaded them. And if you want to move them over to somewhere, for example, I'm going to move mine to the Blender projects folder for me. And I'll just overwrite those because I already downloaded this before. And then we're going to be able to open these in Blender. So we'll head over to Blender, and we are going to open the sci-fi blend. Now, first thing I want to do is save a copy of this in case I mess it up, because that is definitely possible. So we're going to save as, we're going to call this sci-fi edits. I'll call mine sci-fi edits 2 because I already have one of these. And we'll save that. Then this shows us all the animations. I think the save came with a certain layout that I don't usually use, but if we expand this over a bit, you can see all the different animations that this character has by clicking here. And you can see there's a lot of different ones. And yeah, it's pretty cool. We're going to be exporting these with our skeleton, but for now, I'm going to go up to get a different view, and I'm going to click plus, add a workspace, and under general, I will go to layout. We'll zoom in. Okay, so here is our character, and the way that this character is made is modular. So what that means is different parts of it line up. So here I click on the torso and it lines up perfectly, or that was actually the legs I clicked on, and it lines up perfectly with the torso. And you can see that they are the same shape as each other when they meet right here. So to make a modular character, your asset has to be like this. You have to have all the different parts you want to switch out be the same shape at the part that they meet. And fortunately for us, Quaternius has done that work for us, so they've saved us a lot of time in that regard. Now we have this kind of main skeleton with all the different meshes, and we don't really want to delete that, but we do want to duplicate it so we can delete different parts of it. So to do that, I'll go over here to the collection number 1, and I'll right click on it, and I'm going to duplicate that collection, and then I'm going to make it unselectable, the first collection here. So now we have this collection, which actually if we select it and press G to grab, and then press X to constrain grab to the X axis, we could move that over here just temporarily. And there's a reason why you wouldn't want to do this when you export. But then we can show this and you can see we do have a duplicate. Anyway, let us undo all that. So our person is here. You actually have to export your stuff from the middle, or else when you import it into Bevy, it'll be off to the side, and that will not be good. So we will keep everything here, and we'll just hide different parts as we need to. So what we're going to do with this duplicate, which we can rename if we want to the main skeleton, is we're going to delete everything except for the skeleton. So we are right now in object mode of Blender, and we are going to select the legs and press delete. We're going to select the torso, press delete. We're going to select every part that is not a bone and delete the gun. And now we have just the skeleton. And if we move the playhead at the bottom, you can see the skeleton still has this animation effect. It actually stores the animation for all of the different animations on this skeleton. So we would like to export this, and this is what we're going to use as the base for our character. So we'll select it all. We'll head up to File. We'll head to Export, somewhere it is, here it is, and we want GLTF because that is the file type Bevy uses. And we're going to do some certain options here. First of all, we do want the animations for this. Now for include, we only want to limit it to selected objects because we don't want to export the other part. Now we will go to transform. No, we won't. We will go to data and we will go to mesh and we want to apply modifiers. And that is because this mesh has a mirror modifier on it, or this skeleton does. So actually, I'm not sure if it is with the skeleton. With the meshes, you definitely have to do this. I'm just going to keep that on though. Uh, I don't know everything, but it does work if you do this. So I'm going to do it. With the meshes though, you have to turn it on or else you only get half the mesh because one of the modifiers is a mirror. And that is how they modeled a lot of their characters. Anyway, we've done that. So we've exported the skeleton. Now if we go look to, where did I export it? I exported it to my Blender's projects. So wherever you export it, I actually want to rename this to main skeleton. And then I'm going to bring that to my projects, to the folder that we're working with, modular characters and assets, and we are going to paste that in here. So now we have our main skeleton asset. And for now, that is all we need to get started. And later on, we'll come back over to Blender and we'll start exporting other parts so we can have different meshes attached to the skeleton. But for now, we just need that. So with that being said, let us head to the next part where we will import the skeleton into Bevy. So we have exported our skeleton and now we want to load it as an asset so that we can use it. To do that, we're going to create the asset loader plugin. So we'll go to our folder here, same one with main.rs, and we will create an asset loader plugin.rs. I get an error because I have already created this before, but that should go away. Okay, we're going to include this into the file tree, go to main, make sure that you have asset loader plugin there. mod asset loader plugin. And we'll come back here and we're going to set it up. So first thing for this plugin is we're going to have different loading states. So we're going to create a state. And the different loading state we'll have is loading and done. To make this a state, we have to derive a lot of different things on this. So let us derive them. First, it's states, which comes from Bevy prelude. We haven't imported that, so we will do that. And you're going to see states requires a lot of things, so I'll just save it. It'll tell me what to do. So we need to use clone. What else? EQ. You also need partial EQ. I remember this. You also need default. And I believe you need debug. Let's save and see if they force me to have it. No, but you need hash. Okay. Debug is required. Yep. And now we have derived default, but you have to set something as default. So here we will say default. We'll write the default macro here over loading state. So loading will be the default state. Okay. Now we will create our plugin struct. And we will we will implement plugin on this. And you have to provide the build function. Usually I got an IntelliSense for that, but I guess I have to type it in. Okay. And first thing we'll do is we're going to set up the state. This is going to be a state of type. Looks like I got to plug in my laptop. Don't worry, I'll do that soon. Asset loader state, because that is the state we have created. And next, we're going to chain a bunch of methods onto this that are related to the Bevy asset loader plugin or crate. So let me import that. Just use the prelude for now. And this is going to save us a lot more boilerplate over if you watched the last video where we kind of manually tracked if something was loaded or not and then proceeded to the done state. When it was loaded, this is going to handle that for us. Now, I won't pretend to know how this works, but I do know how to type out the code that they provide for me. And the code that I am following along with is on their GitHub here, the Bevy asset loader, and I scrolled down to the collection as maps section because that will let us load our items as a string and then handle. Well, it'll be like more like this one. We'll have a string, which will be the file name, and we'll have the handle, which instead of an image that they're using here, will actually be a GLTF handle. And that will let us loop over all of our loaded assets, which will be very handy. Yeah, so that's why I chose that method. There's a lot of other methods you can use, like you can just set it up as a simple struct and call the name of each one individually, but I want to be able to loop, so that's what we're going to do. And to do that, we will have to write the following code. So we'll chain a method onto this called add loading state. I think something is wrong because I'm not getting my IntelliSense. So give me a second here. I'm just gonna change that. Okay, my Rust analyzer crashed, but we're good to go. So let's see. Dot add loading state. And the loading state is going to be loading state, a struct that is provided to us from Bevy asset loader. And we're going to call new on that, and we're going to pass that our custom created loading state. The loading variant. And when loading is done, we want to continue to state. So that will be done. And the collection we want to load is going to be called my assets, which we still need to create that collection. Let's see if we can just auto format. Okay, so we need to create that struct, which is going to outline how we're going to load our assets from the files. And we have to derive on this something provided from Bevy Asset Loader, which is called asset collection. And we're also going to derive resource, which is provided by Bevy, of course. That will let us use these assets as a resource in all of our systems once they're done loading. And yeah, so right now we're loading nothing though, so we have to say what we want to load. And what we are going to want to load is some GLTF files to start. So pub GLTF files, and this is going to be of a type hash map string, which will be the file name, and handle GLTF. Okay, so this by itself won't do anything because we have to actually specify the file names. Let me import GLTF because I have to manually import it. Sometimes Rust Analyzer doesn't work that well for importing things. Usually it does, but anyway, we're going to use Bevy GLTF GLTF, and that should be good. Okay, so we're going to use a macro on this provided by Bevy Asset Loader, and that works like this. So, or it's done like this. I actually don't know exactly how it works, but we type out asset inside this block here, and here we will pass something called paths, and paths will have a list of string slices, which will be the file names or the path to the file if you have like a subdirectory. So ours is called main skeleton.glb because that is the name of our skeleton that we exported. And if we want later on, we can just add more file name.glb and it will load all of them in this list and add them to the hash map where the string will be whatever you type in here. Okay, besides path, we also have to pass this collection typed mapped. And if you want to learn the why about all that, of course, you can look at the GitHub for Bevy Asset Loader. But with that, we have a very clean boilerplate setup for loading our assets and making sure that we know when they are done loading. So the next step is actually going to be to spawn our skeleton so we can get a look at how that will work in Bevy. Okay. All right, so before we actually move on to creating the modular character plugin, I forgot to uncomment this line in the main.rs so we can actually have our asset loader plugin that we just created be part of the app. And then next we are going to create the modular character plugin. So we'll save this file, go on up here to the directory, and we're going to create a folder because this plugin is going to have a lot of separate files in it. So this is going to be the modular character plugin. And we'll create the mod.rs, save it, add it to the module tree. We'll go back to main, save that because we just added this line via the autocomplete. And we'll go back to mod.rs, and we're actually not going to do anything yet because this is going to hold the plugin, but the plugin is going to have a lot of different systems, and the first system we want to create is the spawn scenes system. So I'll just call this spawn scenes.rs. We'll go here, we'll add that to the module tree, go up to mod.rs, save that so that we actually have that file there. And now we are going to create this system. So this is going to be a function, spawn scenes. And this function is going to need the commands because we're going to spawn scenes and you need the commands to spawn things. And the commands is part of Bevy, so we have to use Bevy, prelude. Okay. Besides that, we also want our assets. I'll just call this variable asset pack, and this is going to be the resource my assets, and that will automatically get imported from the asset loader plugin where we declared it. We are also going to want the GLTF assets, which is a resource that is automatically added in when you load a GLTF from the asset loader, so or to the asset server, I suppose. And this is going to be resource assets GLTF. GLTF isn't part of the prelude, so we will import that. That got automatically imported there. And for now, that is going to be good. We will come back and add some stuff to this later, but for now, we just are going to want to spawn our scene very simply. So to do that, we are going to loop through all of our handles to the GLTF files inside our asset pack. So we have them, it's a hash map, so we have the name as a string and the GLTF handle as the key, or the, I forget what it's called, and that'll be in the asset pack GLTF files field. So if you remember, this is just from what we just created in the asset loader. Oh, I'm struggling here. Okay, here we go. Which was this. So we are getting these, which is string and handle GLTF. Okay. So for each one of those, we want to spawn a scene with the GLTF. But first, we have to actually get the GLTF asset. So this is the handle to the asset. These are the actual assets. We'll use the handle to get the asset. So let's say if there is some GLTF inside the assets, GLTF, and we'll call get, and we'll pass the handle. And should be fine. Okay. If there is one, then we will commands spawn scene bundle. Build up the fields here. For the scene, we are going to get GLTF named scenes field. And I think something is wrong. Hold on. Should be, let's make this default so that we can, otherwise, if autocomplete's telling me something's wrong, then I think I typed something wrong here. Cannot find GLTF. If let some, yeah, that's why. And we have to dereference it. Okay, so we don't call it like that. We just send it like there. I believe this implements copy, but I'm not sure. So, right, so we were getting the scene, which is going to be in the named scenes field. GLTF files will have the named scenes field if you've named their scenes. Since Blender automatically names it scene, then it will be called scene for the only scene we have. And if you had different scenes inside there, you could choose the name here. Like if you had a GLTF file with all your weapons, for example, maybe your scenes would be the name of the weapons. All right, clone that. Okay, so then that should actually spawn the scene. We're not using the name right now. Later we will use it. Actually, we'll use it right now because we want to not only spawn the scene, but we want to have a marker component so we know the name of the scene. But actually, let's come back to that in a moment so we can get something on the screen first of all, because we've been coding a long time and it's fun to see some stuff on the screen. So with this, we should very simply go through every asset, every GLTF that we loaded and spawn a scene for them with all the default location for it and everything like that. So to actually run this, we see it's never used. We have to add it to our main file up here. Okay, so this is going to be a plugin called the Modular Character plugin. And we're going to implement plugin for it. Plugin is part of Bevy, so we have to use it. And this requires the build function. And all we're going to do for now is add systems to the system we want to add is spawn scenes. Let me just delete the actual function call there because you just want to pass the function itself, not with parentheses and stuff. And what schedule we want to do this on is actually when we only want to do it once, right when we're done loading the assets. So to do that, we type on enter asset loader state done, and then that will run this when the asset loader is done. Now there's some kind of problem here because I think we just have to add a semicolon, and that will load everything. So with that being said, we can now see if this works. Let me go to the correct folder. Let's put this on a different screen. Let's zoom in so we can see the beautiful text more easily. And we can try cargo run. Cargo run. I already built it a bit, but if you didn't build it, it would take a long time. And there you go. We see asset loading is done. And we have loaded it, but since it's just the skeleton, it will not show us anything. So for that, just to see if it actually works so we can see if our camera's working and the light is correct and stuff, we're going to go back to Blender and get something that will actually show up here. So we can cancel that. And we will go over to Blender. All right, so in Blender, let us go back to our correct layout. Or the correct view here. I was looking at the animations earlier. And we're gonna uncheck the main skeleton, and we're gonna recheck our entire person here. And once again, we just want to get a part of this. So right now, actually, no, before we split that up, let's just export this whole thing so you can see what that looks like. So we've selected all in object mode, and we'll go to export, and we'll go to GLTF. We will just take everything. Let's include the selected objects actually, because we don't want the extra skeleton. That will mess some stuff up. In data and mesh, we want to apply the modifiers in case there was any mirroring done on these. Like usually you just model the one side and it copies it over. But if you don't click modifiers, it won't export it. So that should be exported. Let's go take a look. So we have this. Let's just call that sci-fi full. And we will cut that. Let's go to the folder we're using. And we can paste that in there. So now we have that. And let's go back to our code. Let's go to our asset loader so we can say which one we want. Instead of the main skeleton, let's go for sci-fi full. And then we'll go run our code here. Hopefully we see that I typed it wrong. The F is not capitalized. And you know what? I'll change it so the naming convention is correct with the other are consistent. Sci-fi full. And if we can copy this, then we will not make any typos. So let's change that here. We could try to run this again. Well, I gotta say, I'm confused. So let's try to figure that out off camera. Okay, so we did not add the plugin to the app. So we'll import that. Now let's see if that worked. And it did work. And if you double click and drag, then you can rotate it around. This is just the default pan orbit camera controls. And you can zoom in and out with the mouse wheel. And if you hold down right click, you can move it around. And that will show us that we are indeed loading something. But we don't want to load the whole thing. We want to do our plan with loading the skeleton and attaching the different parts to it. So this was kind of just a little detour to show that we are actually loading our asset correctly. And I think I will make this a separate branch in the GitHub repository, so you can start from here if you want to skip the boilerplate and just see how to attach different parts. Okay, so let's go to the next part where we will start looking at the scene tree and get a better understanding of what scenes are like once they're created in Bevy. All right, so we are spawning our scene, and now we want to do a little bit of exploration to what is actually a scene. What does the scene look like once it's inside of Bevy? And by that I mean, like, what is the structure of a scene? So this is going to be a section where we explore that by printing out the scene tree, or the hierarchy of all of the entities that compose a scene and the names of those entities, so we can get a better idea of what we are actually working with. This step will be unnecessary if you already know about all that, but I find it was very helpful for me to understand what we're actually going to do to attach the different parts from two different scenes to each other. So with that being said, we are going to get into it. First thing we want to do is to know when we are done spawning the scene, because we wouldn't want to try to print the scene tree if there is no scene yet. And to do that, we are going to utilize states just like we did with loading. So let's go to the spawn scenes file, and we are going to create a state called the spawn scene state. Spawn scenes state. Not a struct is going to be an enum because we have to write the different states. So we're going to have spawning, spawned, and done. We want to have this intermediate uh, state because we may want to modify the scene before we say that we're completely done kind of creating it. Maybe we want to change some of the parts, different scale, or the mesh colors, maybe make them transparent, and then we'll say, okay, we're done. So for this, we need to make it a state, and to do that, we need to derive a bunch of things on it, which we already did in Asset Loader plugin. So I will just look for where we did that right here. I'm copying that, and I'll paste it over here. And we have to declare one of these as default. We'll just make it the top one, or the first one. And now we have this state that we can work with and change. So here in the spawn scene system, we're also going to get the next state, which is a resource of next type next state, spawn scenes state. And we are going to change that when we are all done spawning scenes. So after we've looped through all of our scenes, we are going to set the next state by saying next state dot set, and we want to set the spawn scene state to spawned, and that will be accessible in our main function for this plugin. So we'll go over here, and then we're going to use that state when we run another system, which is going to be the system to print the scene tree. Since we haven't made that yet, we won't add it here yet. So we're going to come up to this, and we're going to make a file called print scene tree.rs. We will do all the things we normally do to make sure it's available. Not sure if that worked. I think I just didn't press the button enough. There we go. We've added it into the tree. Oops, that's the one we want. Okay. So to print the scene tree, we're going to do a bit of recursion, And to do that, well, I'm just going to copy through the notes. So we're going to create a function called walk tree. And what we need for this is all entities with children, which, which will come from a query that we're going to make in the actual system. So this is going to be a reference to a query of things that have the children component. And that is not what we wanted. We need to import Bevy because that's where children comes from. Okay, let's get rid of this error here. Okay, besides all entities with children, we're also going to want the names. And names is a component that gets automatically added when a GLTF scene is created. It will use the names of the different nodes in there if they have names and add them to this um, object that holds all the different names for things. And then you can pass an entity ID and get the name for it from this. What have I done here? Okay, here we go. It's a query. Okay, well, it's a reference to a query because we are going to actually do the query in a system. But this is the recursive function that we're going to call inside that system. Okay, we also are going to want the entity that is kind of the current entity that we're looking at in the tree. And that's just going to be a reference to an entity. And then we want the current depth, which is how deep in the tree we've gone. That's just going to be a unsigned 32-bit integer so that we can print out how like tabbed over it will be because we're going to print it out kind of like a file tree. So like when you expand one folder, it shows you the ones and it's a little bit tabbed over to the right. Okay, and that is going to be called our padding. So we will declare a variable for that. Which is just going to be an empty string. And then we're going to modify that string based on the depth. Oops. It's just going to be a range from 0 to the current depth. We're going to push a string slice of dash onto it. And however deep it is, it'll have that many dashes in front of the name that we print. So then we have to say, if this thing has a name, names.get gives you a result, so you have to say okay instead of some. Then we will print out this formatted string, which will start off with how much padding we have. And then this debug print, and that will have the name. And we also want to show the entity ID. Some of them won't have names, but it's just nice to see the entity ID. And we will put that in parentheses. Okay, so if this has a name, we'll see what is the name and what is the entity ID. But some of them will not have names, so we'll say otherwise, else. And let's just copy that for the moment. And we'll say this is an unnamed entity and delete name because we're not going to have a name. Okay, so this will print that all out for the current entity, but then we also want to look at all of its children and print that out as well. So we are going to do that. It's going to be depth first. So we're going to go to the deepest or like the most childest child of the first entity we pass it, print out all of its children, then go up to the parent, like the next most deepest one, and print it all out. And that is how it gets printed out when you look at a file tree normally. Okay, so let's get all the children of the current node, or current entity, I guess you could say. And to do that, we go to our all entities with children query, and we will just call get entity. And then we will see all of the children of the current node. So we are going to start off with the root node, which is going to be the scene entity. And then we're going to get all of its children, and then we're going to call this same function on it for every single child, and that will search all of them and print all of them. So for child entity in the children of the current entity, we'll just call this same function. And we would pass everything the same, except depth is now going to be more because it is the child, so it's deeper down in the tree. Oh, and we do not want to pass entity, we want to pass child entity. Okay, so we will call it the same function, but with the child of it, and then it will look for all the children of that, and so on and so forth until there's no more to print. So this is our recursive function here, but we actually have to call it, and the first thing we want to call it on is the scene. So to get that, we'll make a system called print scene tree. So here is where we actually get our queries, because this is going to be like a normal system. So scene query is going to be a query for entity with, okay, scene name. Now we actually didn't make this yet, I've realized. So I sort of skipped over that so we could render something on the screen earlier, but we have to have this marker component so we know which entities are actually scenes. So let us actually come back to this because we have to set up this marker component when we create the scene and spawn our scenes with a scene name component, and that way we can query for every entity that has the scene name component, which would be the entity that is a scene. So let's go up to spawn scenes, and in here we're going to create that scene name struct. And we'll derive component on it. And debug as well, so we can print it out. And when we actually spawn our scenes, instead of just spawning the scene bundle, we'll make it a tuple. I just added parentheses around it here. And the second thing we want to pass in the tuple is a scene name, which will have the name of that scene, and that will be gotten from the file name, which we left unused here, but let's call that file name. We could just call it name. And that will be a string, which will be the file name that we got from the asset loader. We'll pass it here and clone it. I think I have to do like this. Oh, okay. This is the problem. I declared it wrong. Okay. All right, so that should be good. We'll have the scene name marker component here. All right. So now our scene bundle entity will have, or our root scene node will have the scene name, so we can actually find it here. Let's come back. We'll uncomment that. And now we get all entities that are scenes. Next thing we want is to get all entities with children. And instead of a reference to query, it'll just be a query. And we also want names, which will be a query for names. And once again, names gets added automatically to the entities that have names inside the GLTF. And for every scene that we have loaded, we'll print out the scene tree. And here's where we have to pass as references. The depth will first be 0. And we have to import that. This will be scene entity. And this is just name, not names, and it has to be a reference when we query for it because it's a component. And there's yet more problems here. What does it say? Oh, I declared this wrong. So we're getting entities with scene name, or we were only getting the entity, but I want the name also. Um, we're probably we're probably not going to use it at this moment, but if you want to say which one you want to print, if you have multiple, which we will, then that will be good to have. So let's get the scene name along with that. And we need to borrow that. And that will say it's unused, so we can just not take it at the moment. And now we have the print scene tree system, which we can use to recursively look at every node in our scene tree. Then let's take that and add it in to our systems here. But we don't want to keep printing it forever, so we will add it specifically to when we are done loading the scenes. So that will be on enter, spawn, scene state, spawned, and the system is going to be print scene tree. Just automatically import it like that. But when it does, I have to delete the function call there. And that should not work yet because we never initiated the state. So I'm not getting an error, but I want to make sure we initiate the state here, or initialize it. So we have that starting off at the default state. So we'll add init state, spawn scene state, and then it will be in the default state of spawning before it is done spawned. And in spawn scene state, we'll change the state to be spawned, and then it should print the scene tree. So let us go over here and run it. And here is the scene tree for this character. So let's take a look at it. Let's go up to the top. And we got a lot of interesting things here. We've got the character armature. Well, first of all, we have this unnamed entity, and that is the first node of the scene, which is actually the scene bundle entity. Then we have the first child of it, which I don't think there is anymore on depth 1. Yeah, if we look to the bottom. So that is the only child that comes next to it. Then we have the character armature at depth 2, which I think there's also no more depth 2 things. Yeah, it doesn't look like it. So everything after this would be a child of character armature. We got the sci-fi body, which has a bunch of different meshes that don't really have specific names. We have the feet, same thing, it's made up of some sub meshes, and the head and the legs. And then we get to this thing called root. And root is the first bone in the tree of bones. And a lot of the bones are a child of root, and then it kind of goes in a one down the line. They're all like children of each other. And yeah, so these are all of our different bones. Now I will show you that if we only import the skeleton, we should see this scene tree here, even though we won't see anything over there. So let's cancel that. Save this. Let's go to our asset loader, and we'll get the main skeleton. Let's run this. And here we see a very similar thing, but you'll notice those meshes aren't there. So we, even though we don't see anything, have this scene that is loaded, and it has only the bones. Okay, so with that, we have printed the scene tree, but it will be interesting to see the location of the bones in space. So this is another sort of research segment that's going to help us understand things. And to do that, we're going to print a cube or paint a cube or create a cube, whatever you would say, on each of those bones in the 3D space so we can see their locations. All right, so this is going to be another section that is just to help us build our understanding. And what we're going to do is paint some cubes onto all of the bones in our scene. And to do that, we're going to create a system. The system is going to be called paint cubes on joints. And this is actually, joints are what the bones become once they get put into a GLTF, because GLTF has no idea of what bones are. They call it joints, which is pretty similar. So we are going to add this to the module tree, just how we've done it in the past. And here we are going to make a system which takes in a lot of arguments. So let's declare that paint cubes on joints. We're actually going to paint some cubes on some of the other children, but it will mostly be to look at the joints. Okay, so let's get our different arguments here. We need commands, because that's how we're going to spawn the cubes. We need a scene query, because we need to find our scenes. And that is going to be a query for entity with scene name. Scene name was declared in the spawn scenes system file, so we will import that. We also want to get all entities with children, which is a query for any entity that has the children component. Now, this seems to be declared wrong as a function. Yeah, it is. I put the wrong type of braces here. That's why it's looking all weird. Let's just fix that. And yeah, all these things have in common is that they're from Bevy, which we did not get the prelude yet. And next, we want our materials, which is a resource that we're going to add a material to. The material being what color our cube will be. Next, we need the mesh handles, which will be a query for a reference to handle mesh. And this is because we are going to want to not put cubes on the mesh children of the scenes. We only want, you can obviously see the mesh already, so we want to only look at the bones and add a cube that we can use to see the bone location. And then we're also going to want meshes, which is the resource, mutable resource, because we're going to add a mesh, which will be our cubes. And then we also want global transforms. So anything that has a global transform component, and we're going to use that to only put cubes on things that have a location in space, because there may be children of the scene that doesn't have a transform, potentially. So with all of that declared, we're going to loop over all of our scene entities. In our scene query. And we're going to declare what color we want the cubes to be. I'll make them a red color. So they're easy to see on our background. And then we want to look at all the children of the scene. So to do that, we can use the iter descendants function. And we'll pass it our scene entity. And we'll enumerate them. So we can, this will tell us the number. Actually, I think we don't need to enumerate them because we're not using the number really. I was using that earlier for some other parts, so we can omit that. So we'll just look at every entity that is a child of scene entity by using this iter descendants function. So you might think, why did we not use this to go through the scene tree before? Is because this traverses the hierarchy breadth first. So it looks at the top node, then it looks at all the children of the top node, then it looks at all the children of each of those, and it goes down in a way that wouldn't have been suitable for printing out a file tree type of thing. But this will be fine to loop over all of the entities, all the children of the scene entity, if we don't really care what order we do it in, or if we prefer to do it breadth first for whatever reason. I think I don't care how we do it and for putting cubes on it. So for all of these entities, we just want to make sure that they are not a mesh, or that they don't have a mesh, because if they do have a mesh, you could already see it, so you don't need to put a cube on it. Plus the cube would probably be so small it'd be like inside the mesh, so you wouldn't see it. So let's make sure that there is no mesh by doing this. If it is an error to try to get a mesh from it, from that entity, uh, sorry, if we look at the mesh handles and try to get a mesh handle that is associated with the current entity, then it should be an error if it has no mesh. And then we want to put a cube on it. We also only want to put cube on something that has a transform because the transform has the location. Otherwise, putting the cube on it would not matter because it has no location to look at its location. So if there is some global transform for this entity, you could probably also just do regular transforms, but pretty sure all bundles get spawned with both of them. And we need to put an equal sign here. Then we've met all of the conditions that we want to spawn a cube. To do that, we're going to make a mesh for it. So let's get the handle out of that when we spawn up or when we add a mesh. To spawn a cube, you put the cuboid in here and then you say how big it is. A good size for us is going to be 0, 0.01 by 0.01 by 0.01. And then we'll have this handle to the mesh. And we can also make the material so standard material. The base color is going to be cube color. And the rest will be default. Now I'm starting to believe, in retrospect, that I don't need to add the material every single time in the loop. So I'm going to try to do it outside of the loop. A little bit of live editing to my notes here. If that doesn't work, we'll just put it back inside the loop. I believe the reason I was doing it in the loop is because I was originally changing the colors of the cubes for each one. So this should probably work. We'll give it a try. So now we want to actually spawn the cube. So we will commands spawn very similar to how we spawned our scene, but this will instead be a PBR bundle. The mesh is going to be the cube handle. The material will be the cube material handle. The transform is going to be a transform of nothing, basically, or it will have no additional transform to it, but it will follow the transform of its parent once we make its parent the bone that's going to go on. And the rest of this will be default. I wonder if I even need to include the transform there. We may be able to omit this because I feel like the default is 0, 0, 0, 0. Let's try it as well. We're trying things right now. Now we've created this cube, but we want to set its parent to be the current entity, which would be most likely a bone. To do that, we actually need to get the entity commands for this entity we're spawning. So we can just say, we can get it from the commands.spawn. It returns that. I need to just delete that. So now we have entity commands. Entity commands is how you can set the parent for an entity. So entity commands set parent function, and we will make the parent to be this entity, which is the current entity we're looping over in the children. And we cannot mutate it. I think we need to set this as mutable to do that. And now we should be able to see cubes here. So let's add this system to our plugin here. We also want to do this at the same time as spawned is complete, that at the same time that we print the scene tree. So instead of just passing this, we'll make it a tuple, and we'll add in paint cubes on joints, which we need to import it somehow. That should do it. So let's take a look and try to run this. And here we can see that our skeleton bones are all painted with a cube. Now, what would be nice is if we knew the name of each one of these, so we could just see which one is which. So we can do that pretty easily, and we will do that in the next section. So if you remember in the beginning, we added this dependency called Bevy mod billboard, which will allow us to print out some text in the 3D world, and it would look like this. But what we actually need is to get a font that we can add as a resource so we can have a font to print the text in that font. To do that, we are going to download a font, and you could download any font you want, but I'll use the one that they use in the example called Fura Sans. So we just look for that, and it is Google font. So you can just go here and download it for free. And let me just remember how to do that. Okay, just have to dismiss that. And we can download all. It should be downloaded. So we will go open it. It will be in whatever folder you download it to. We can extract it. Now, I don't need all of these. I only want the regular one. So I'll take that, I'll cut it, I'll bring it over to my project folder, and I'll put it in the assets folder. Then the rest of this can be deleted. So now we have this in our assets folder, but we have to load it using our asset loader that we set up earlier. So we'll go over to that. And here we have already GLTF files, but this is not going to be a handle to a GLTF. It's going to be a handle to a font. So we'll copy this, but we're going to edit it. First of all, the path is going to be the exact file name of that font, which I forget what it is, so I will go look at it. Actually, I'll just copy it. Copy it with the extension. And this is also still going to be a collection typed mapped. It's going to be a hash map for a string of the file name, but the handle is going to be a handle of font. And that should be good. I have to call it font files. Well, you could call it anything you want, you just can't name it the same as the one that you already have. And now we will be loading that. Now let's go back to where we're putting the cubes on the joints, and we could make a separate system to name them, but we're already looping it over everything here, so we might as well just add the labels in to this one. So let us load our font here, or rather it is already loaded. So let's get that from our asset pack. So to get that, we have to use our asset pack or up here. So let's take that as an argument. This is our resource that we got from loading during using Bevy Asset Loader, and that is my assets. And that got automatically imported by my editor up here. And we call that font handle. It is asset pack font files, and we're getting the exact correct name. And it will return an option, but I will expect to have loaded the font because we are setting that state and waiting for that state to change. And it should only pass into the loaded state if we do load it. And if something goes wrong, we'll know why it went wrong from that message. So now we have our font, and we want to use the Bevy mod billboard to draw some text in that font. So for that, we will make it immutable entity commands for this because we want to be able to set the parent of this once we create it, so it's in the right location. I'll call that billboard entity commands, and that equals commands dot spawn, and this is a billboard text bundle, which comes from Bevy mod billboard. So let's import that. Maybe it automatically imported. Yeah, okay, it automatically imported. And the fields for this, let's just fill them automatically so you can see. There's a lot of them. We're not going to fill them all ourselves, but let's start with the transform actually. The transform, we are going to change a little bit from the basic because we want to go above the cube. So we'll 0 to 0. For the y, which will be the height, we will do 0.01, so it's not right on top of the cube, and 0.0 for the z. And we also need to scale this down because the default scale for the text is, actually I didn't play with it too much, but this is how I got it to work. I'm sure you could do it differently because, all right, let's just delete those. Because I'm using a really big font size, but I played around with the different font size and it was hard to get one that was the right size, but also not low resolution. So for the text, we are going to set that to text from sections. This is all explained in the Bevy mod billboard GitHub. So that's what I'm basically copying it from. We need to have a value. And for now, we don't have the name. We're not getting the name yet. So I'll just say some name, and we can fill that in once we see that it's actually printing the text. The style, this is how we're going to set up the font and the font size. It's going to be a text style. And the font size, we'll do 60.0. This is the part I'm not really sure about. How, like, do you really need it to be that big of a font and scale it down? I don't know. But you can play around with it and get one you want. For the font, we'll use that handle we got from up here. And the color, we'll just make it white. This comes from Bevy. It's just a included constant. Oh, sorry, typing Bevy. White. Okay, for the rest of the fields, we'll just do default, and format needs to be called like that. So now I think we should have the word some name being printed over all of our different cubes. No, with scale. Oh, this requires you to pass a vec3, and you can do this splat. I don't know why it's called that, but it just makes the vector with all the elements set to the argument you pass, so you don't have to type all three of them. So that would be probably fine. Let's try it. And, oh, I see what mistake I made, but here you can see it says some name only down here, which is the zero dot, it's like the 0th location. It is the world origin, I guess you would say. We never set the parent of each one to the cube, so that's like a bunch of them stacked up on top of each other. Okay, so that's why we got the commands here in the first place. So under this, once we've spawned it in, we'll call set parent to, I forget what we call it. It's just called entity. Now let's give it a try, run it again. And here we go. So every one of them has some name, but we want to see the actual name. Looks kind of crazy near the hands. Okay, so let's get the actual name. To do that, we have to get the names like we did before when we were printing the scene tree. So this should be a query name, and we will get that name at a certain point. I suppose we can just do it here. Now that will be actually a name result. So if there is a name, then, well, I'm just going to make a variable called name. And if there is actual name, then we'll return the name. If not, we'll just return a different string that says it's unnamed. So this will be name. Actually, I think we have to format it. Else. We'll just do that. Probably toString. Format returns a string. So this should give us the name of our entity. So we can put that here instead. And now it should tell us the actual names. And here you can see that it is showing us the correct names, and this will be useful not only for the curiosity of it, but once we spawn in another part, we can see that we like overlap it, and we can make the text for that one appear a little bit above that, and we can verify that we are lining them up correctly. So interesting thing about where do these names come from is they come from what you name it in Blender. So let me show you that. Over here, if I click on this and I go to edit mode, then we can click certain bones. If I click on that, you can see up here it says upper leg L, upper leg R. This is like head, I think. And there's these bones out here. So if you don't know about these bones, it's called a pole target. So if you move this, the leg will rotate to face towards it. I think I could show you that. Pose mode, click on that. Let's grab it with G, and you can see it's pointing towards that. So that's what that bone is for. That always confused me. The first time I read pole target in the GLTF file, I was like, yeah, it's like for holding a pole weapon or something, but that's not what it is. It's pole like North Pole. Okay, so yeah, we've done that. We've taken a look at putting all the different names on our different uh, different bones or joints. Some things that were not joints that we got here are the character armature. So that's not a joint, that is the parent of the root joint. And we can see in the scene tree character armature. So that will be important later. This doesn't get animated, like it doesn't get moved by the bones, but it is the parent entity. So we will have to keep that in mind for the future. In any case, the next thing we probably want to do is spawn in a part for this and attach it to the skeleton. So we'll do that in the next section. So we want to spawn in another scene that will be one of the parts that we're going to use to assemble our modular character. For that, I've come back over to Blender and we are going to hide the main skeleton. We're going to show our full character and then we are going to duplicate that collection. So up here in the top right, we'll right click it, we'll duplicate the collection. And if we want, we can rename this collection using F2 to something that makes sense. We could call this the torso. And we're going to edit this. So we want to hide the main collection again so we don't accidentally delete parts of that. So here we are going to delete certain sections of this. Now I would caution you, because I made this mistake, that if you wanted to like look at both of them and you move this one over here and you started to export parts of it from this location down at the bottom, this root node is like its location, whatever that is, then when you put it into Bevy, it will not work right. It'll be off to the side. So you want to make sure that it stays in the center. Then we are going to make sure that we delete the parts that we do not want. So this is just the torso. We can click on the head. We're in object mode right now. We can delete the head. We can delete the legs. We can delete the boots. And we can delete the gun. And now we could just export this and it would be fine because it would match up all the bones, but some of the bones aren't necessary. So I know, for example, that we go to, actually, we can go to pose mode and we can see which bones actually affect it. So if we take this and try to rotate it, uh, the only bone that's really changing is this one is changing it. So let's actually do that one. You can see that, let me grab it. Let me grab it better. Yeah, so that one affects it, the top one, but the shin and the feet do not. So let me just undo all that business. And in edit mode, we'll delete this bone, this bone. I'm just clicking on it and pressing the delete button and I'm clicking bones. We'll come down here. There's one bone we need to keep, which is this. This is called root, and every bone is a parent of that, and you need to keep that because of the method that we are going to use. Now, your skeleton's bones might have different namings, but whatever you name it, whatever is the topmost bone, the most, like the highest parent bone, keep that one because we're going to use that one to look at all the children of it to match up all the bones once we get into Bevy. So anyway, with that, we're going to delete the feet bones. We're going to delete the pole targets because the pole targets don't affect the torso. They more so change these, which in turn affect the torso, but we don't need that for this. We also probably don't need the head, but let me just double check that by going into pose mode and rotating it around, and we can see, oh, it actually is changing it. So we'll keep the head. I think I deleted it in my original research for this, but I didn't notice it was changing that. So you got to be careful. Make sure that you don't delete any bones you don't actually need. And this, deleting the bones might not even be necessary if you don't care about the minor performance loss from having some extra bones. So let's select it all. Make sure you do select the root bone at the bottom. And we'll go to export it. So we'll go File, Export, GLTF. We want to make sure that we do not take the animation data because that would just be a waste of space because we're only going to animate the skeleton. Then we only want to take selected objects or else it will export all of this. And in data, mesh, apply modifiers to make sure that we get the mirror modifier and we will export this. Think of that as done. And come back over here and find that. We want to rename this to sci-fi torso. and we'll bring that over to our assets folder. Once we've done that, we can load it using our asset loader. So we'll come back over here, and inside paths above GLTF files, we're going to add the sci-fi torso.glb to the list. And this should now spawn in once we run our program. So let's go over here and run it and just see that it will spawn in. It did not. So let me see what went wrong. Okay, so what I believe went wrong is I did not correctly select everything when I exported, so that's an easy mistake to make. So let's make sure we are in object mode, select everything, make sure the mesh is also selected. I think I only selected the skeleton for that. And we'll just export it correctly, like before. Maybe it saved all our preferences. Looks like animation's unchecked. We're only selecting objects, and we are applying the modifiers. So we'll try that again. Name this sci-fi torso again. And we'll overwrite it. And we should see if it works now. Yeah, it works. So right now they're spawned on top of each other, but they're not actually attached. So if we were to animate the skeleton, nothing would happen with our mesh here. To further demonstrate that, I will try to move this over a little bit. So we can start with some sort of x, which will be 0.0. And when we spawn our scene bundle, we can say the transform is from transform from XYZ. The X will just pass the X, Y will be 0.0, Z will be 0.0, and then the comma there. And after we spawn each one, we'll increment the X a little bit. It needs to be mutable. Now let's see if it moves it over a bit. Yeah, so, okay, it actually spawned that one first and then moved that one over a bit. So you can see they are separately spawned, so we need to attach them to each other. To do that, we are going to make the parent of each one of these joints the corresponding named one of the skeleton. But I think what would demonstrate that even better is if we actually animate the skeleton first, so we can see that animating, then we will attach it, and then we will see the torso start to animate. So that means we have to start doing the animations part, which is going to be very similar to my video about animations in Bevy, which is the previous video to this. So we will go over that pretty quickly. I'll probably not code it one line at a time, and I'll just paste it in and explain it. Okay, so to add our animations in, we are going to make a resource up at the top of our spawn scene system, and it's going to be called animations. Well, we're making a hash map. We actually have to create the resource up here. So this is going to just be a struct called animations, and that will contain a handle to an animation, or this will contain a hash map of names and handles to animation clips. So hash map, string, and handle animation clip. We have to make sure that this is a resource by deriving that. Might as well put debug on there just in case. And then while we loop through the scenes, we're going to check if they have any animations in them. Or well, while we loop through the GLTFs, we will see if they have animations in them. And if they do, we will add them to this animation clip hash map and then add that hash map as a resource. So here we will loop through all the animations in this. So I'll type it out, I suppose. Oh, you know what? This has to go up here because this is where the GLTF actually is. We can print it out so we can see that all the animation is getting added. So that would be a string. And we can index into named animations with the name of it, and we'll clone the handle. And this was gone over a little bit more in depth in my previous video, but basically we are inserting all of those animations by their name into this hash map, and hash map requires importing hash map. Okay, now once we've done that, we've collected them all in a hash map, we have to actually insert the resource. So to do that, we'll do commands.insert resource, and the resource will be animations, with its one field being animations. So this is this. Oops, don't want to do that. Oh my gosh. And this is from here, where we collected them all. All right, so let's just see if it actually is loading the animations. Let's head over and run this. Scroll through all that, and we can see it's inserting all the different animations that are in the skeleton's GLTF because that's the only one that we exported animations with. So we have our animations, now we want to run our animations. And before we can run them, we have to do the whole topic of the previous video, which is link the animation player entities, or yeah, there's like an animation player component on one of the child entities of the scene. It needs to be linked up to the scene so you can select which scene you want to animate. And I think for that, we are just going to mostly copy some code. So here we'll do link animations.rs. This will be the system that links animations. For a very in-depth explanation of this, check out my last video. But let me go find the code to copy for that real quick. So I just made that file, and this is a system that links the animations up. Yeah, for very briefly, what this does is, well, when you spawn a scene, it's gonna check if there's some animations associated with it, and if there are, it's going to attach an animation player to one of the children of that scene, which will probably be the parent mesh of whatever is getting morphed by the animation. And there's not really an easy way to get to that animation player to tell it to do things unless you link it up to the scene bundle top entity, like the top parent of the scene. And that is what this code does. There is a whole video about this, so go look at that. Otherwise, you can just copy the code here if you don't care. Now we have to add that system here in after they are spawned. We want to link the animations. Okay, so that should link the animation player entities correctly. And then we actually want to run the animations. For that, we will create a new system. We'll call this run animations, and we'll make sure it's included in the tree. Okay, so for this, we are going to need an additional part of our scene spawner system. The reason is because we want to only animate the skeleton. And when you query for all scenes to get the scene for the skeleton, you would have to loop over every scene and then check if its name is skeleton. But instead of doing that, we want to specifically say we want the skeleton scene. And there's not a built-in way for that, so you have to do this extra little bit of setup to keep track of your scenes or your scene entities by their name. So for that, we will go to spawn scenes and we're going to create a new resource, and that is going to be called, I'll just copy this resource. That's going to be called, oops, scene entities by name, and it's going to be a string and a and an entity. So just kind of like how we collected our animations into a hash map, we'll collect our scene entities and map their name to an entity so we can easily access specific scenes, just like that. So we'll say scene entities by name. And as we loop through our GLTFs, we'll build this out. So for that, we need to get our entity commands so we can find out the entity ID of the scene once we spawn it. So when we spawn it, it'll return entity commands. So let entity commands equal commands.spawn. And then we can get the entity for that with the ID function of the entity commands. That will return you the entity. And then we'll just insert that into our hash map. The name will be the name of the GLTF file that we're looping through, and the entity will be the entity. Entity implements copy, so it will just get copied here. So now we have this collection, or this hash map of the name and the scene entities, but we have to insert that as the resource, just like we did with the animations. So down here, where we insert the animation resource, we can do the same thing, except change the name, scene entities by name, and this is scene entities by name, the hash map. I think I've done something wrong here. Okay. Name is a string. I think I just have to clone this, perhaps. Yeah, because it was just a reference to a string. Okay, so that should be good. And now we can go to what we originally wanted to do, which was run these animations. All right, so we know we are probably going to want the Bevy prelude, so let's just get that out of the way. And we're going to make a system here called run animations. And we're definitely going to need some arguments here for that, such as the animation players. So we're going to get all entities that have an animation player. And we need it to be mutable so we can change what animation it's doing. And then we need the scene animation player link query so we can associate animation players with the appropriate scene and only animate the scenes we want. So this will be, we'll get the scene name and the animation entity link, which has to be imported from our link animations system. And we only want, if they're just added, the link, because we're only going to change the animation at this time. But if you wanted to change animations throughout the game, you would have to do it differently. We're only going to start an animation as soon as we see that the animation player has basically been linked to its parent scene. Now let me auto format it so it looks good, and we have to import the scene name. Okay. Next, we also want all of the animations from the resource of animations that we collected when we spawn in the scenes. Okay, just double checking that was our custom one that we made. And then we want the scene entities by name, which is our custom resource that we just created. So with all of this, we should be able to target the skeleton specifically out of all the scenes that we have and animate only the skeleton. So first, we need to get the main skeleton scene entity. And that is going to be gotten by scene entities by name. And we'll get, and we need to type the file name exactly as it is. And that should be correct. And since this will be I think a result, hold on, no method named get. Oh, because this is a tuple struct and you need to have you need to index into it. So that should be an option. Oh, it's an option. Okay. Anyway, we are going to expect this to be true because we know that we set this up when we spawned the scene. So we'll say to expect the scene to be registered. I would just call it being registered is when your scene name is added to this scene empties by name. Okay, we have to make that public clearly. So let's go to the definition of that. And let's make this public. I'm pretty sure we're going to need to make this public as well. All right, so we have our main skeleton scene entity. Next, we need to get the animation player entity link. So we will do that. And we will get the, or hold on, let me type this out. We'll get the link here from the scene and animation player link query. It's probably worth looking at what that is, just so since we skipped over it a lot. Um, yeah, so an animation entity link is just something that holds an entity, and that entity will be the entity that has the animation player that is the child of the scene. So let's go back here. So we want to index into the scene and of all the entities that have an animation player link in them, we only want to get the entity that is of the correct name, which is why we wanted to get the main skeleton scene entity. So we'll copy that, paste it in here. So basically we're asking for in this query, which is every single scene that has an animation player on it, if you had multiple, although I think we will only have one right now, but if you did, then you only want the one that is named main skeleton.glb. And let us also expect this because we have spawned the scene. And now we will have that. Now this is a link to the actual, or this will have the entity of that actually has the animation player on it. So we need to actually get that entity. It's a bit convoluted, and I wish this was easier in Bevy to do, but it is the way it goes. Once you get it set up, though, it's not too bad. Oh goodness. All right, so let's look at this that I just typed out. So this will actually be the animation player because we query for all animation player components. And these will, you can just get whichever entity out of this query based on the entity ID you pass to get. And the entity we're passing to it is the entity from the animation player links that we queried for only the skeleton. So I know it's like a long chain of stuff to do, but this is how you get a specific animation player to start an animation on it. So now we actually will play an animation. So with our freshly gotten animation player, we will call play, and it's going to be animations. Animations is our resource of animations, dot zero, because it's a tuple struct with a single field that holds our hash map of named animations. And we will get, and we can type in the name of an animation. Now, if you don't know what the name of the animations are, you can both find them in Blender under animation, and then in this action editor, they are right here. Also, just in Bevy, when we were printing everything out, when we collect our animations, we see inserting animation of all these different things. Also, if you're using GLTF instead of GLB, you can look in the actual file, find the names. Of course, if you create your own assets, you probably know what the names are. So let's get a nice animation going on here. I like to use the /1, so we could copy that. If I could copy out of my terminal, let's see. Okay. And we want to repeat this animation so you can chain on to this. So, repeat, and you can change the speed. I like to slow it down a little bit. And there's some problem. Oh, let's change this to animations and delete that because that got accidentally imported when I named it the wrong thing. And we still got a problem. Oh, that's because this is an option or possibly a result. So let's us expect it to have the to have an animation by this name. And I think you have to clone weak this, which is something I never fully researched, but it is what works. So I've typed it in there. So I believe this would now animate if we have to add it the system. So let's add the system in. We want to do this. I suppose we could do it here, um, but I will do it after it is all done there. So let us, you know what? For simplicity, we'll just do it right here. I was gonna say we would wait for this to be fully like edited here. We can always change that though. Let's just get this running though. Shouldn't be any problem to do it in this stage. So let's head over. Let's see if we indeed have it animating. I guess we don't. So let's see why. Okay, I'm pretty sure the reason why is that we do have to wait for the next stage because the animations have not been linked yet. So let us remove that. We're going to have one of these, let's have it be in the linked animation, set the spawned state to be done. So let's go to link animations. We already have this next state here, and we already set it to be done because we copied pasted this from the previous video code. So let us now go here, and then we'll just add systems on enter spawn scene state, done. And here we'll just have a single system, which will be run animations. So hopefully that will be the answer to all our problems. Let's give it a try. And we can see our skeleton is actually animating, and that is great, but we still need to attach the part to the skeleton and have it follow the motion of the skeleton. So we'll do that in the next section. So it is finally time to try to connect our part to our main skeleton. And to do that, we are going to create another system. And that system is going to be called assemble parts. But we do actually want to put that into another folder because that has a lot of functions that make sense to put into separate files. So we'll create a folder called assemble parts, and we'll go into there, create the mod.rs, we'll include it, we'll go and save that. And here we're going to create our function. Definitely going to need the Bevy prelude. And we're going to take in some arguments here for our system. First of all, we need commands because we're going to be setting the parents of our bones, and you need the commands to do that. We are going to need the scenes. We also want the scene name component for them, so we know exactly which part we're getting, or if it's the skeleton. We also want the scene entities by name, which is our custom resource that is a hash map of all the scene entities by name. Then we also want the transforms, and that is because when we parent the bones to the main skeleton, we want to make sure the transforms are completely zeroed so that they don't have their own transform that was like interfering with. We basically want to exactly be the transform of its parent and not have any of its own local transform get copied over. Then we also want names. Because we want to know the name of all the different bones and make sure they match up with the proper bone of the main skeleton, which will have the same name. So first thing we need to do before we can attach the bones to the skeleton bones is actually collect all the bones and have them in a way we can work with them. So for that, we're going to have this function called get main skeleton bones and armature. The armature isn't a bone, but since it's the main parent, we will want to also attach the armatures of our different parts to the main armature. So this is going to return exactly what it says it returns, which is the main skeleton bones and the main armature entity. So since this doesn't exist, we have to create it. So we'll copy that. Let me put the underscore there, and we'll comment that out right now so we don't have the errors. Also, it looks like we need to import the scene name. Okay, so let's create this function, but we will create that into a separate file because if you put it all in this one file, it will be messy. So we'll go to this folder we made and we'll create that file. And let's include it and save that we included it. And here, we're going to work on this next function. So for this function, we are going to require that we have the scene entities by name. And all entities with children. And the names. Okay. And this is going to return a hash map, which will be keys of string and value of entities. So that will be all the bones. And we're also going to return the main armature entity. And let me wrap that in parentheses so that it's a tuple. So let's set those up first of all. So we can say that bones is its own hash map. And main armature option is none to start off with, but we will return it, or we will expect it later. And then we can return that. And we'll expect this, the main skeleton to have an armature. But right now, there's some problems. Let's import hash map. Let's import the Bevy prelude. This is name, not names. And that must be a reference. So, okay. So we actually have to now get these main bones. First of all, we want to make sure that we're only working with the main skeleton. So that's why we have all our scene entities by name. So let's get the main skeleton entity. And that is indexed by its file name. And we have to expect it. So we expect to have spawned this because we are only going to do this in the state where we have spawned it. And then we are going to get the root bone and iterate through all the children of the bones to collect the bones. So we'll say let root bone equals, and this is a function that we haven't created yet, but we are about to create it. Find child with name containing. So we want to find the child of this scene that is called root. The reason is, if we look over in the layout tab for Blender, this bone down here, actually let me switch into edit mode. This bone down at the bottom is called root. And you can see over here in the top right that the character armature is the main parent. Then there's this armature too. Then there's root, and that's a bone. Then its child is body. Their child is hips. But basically, the root is a bone, and every other child of this is a bone. And that's how we know that we are collecting only the bones, is by looking for the child of the scene that is called root. If you name it something that's not root, you will choose a different name in Bevy when you search for it. But that will give you all of the bones. So let us create this function called find child with name containing. Okay. Let me create that in a different file. We'll use this to also get the armature later. So let's save the file. Let's add it to the tree. Let's save our mod so that we have it actually imported. And let's build this find child with name containing function. We are going to use Bevy once again. And this is going to be a breadth first search of all the children of this entity, which will be the root. The reason we want to do breadth first search instead of depth first search is because you want to find the child with the name as soon as possible. And we know that root is one of the higher up children. It's one of the earliest children in the tree. So you wouldn't want to search like all the way down to the bottomest bottom of some node that isn't going to contain it. You just want to find it faster. So let's create our function. I think I copied this. Yeah. Okay. And let's get our, well, let's do this. We know we're going to return an option entity because maybe there is no entity with this name in it. Okay. Now, oh, well, so make the error go away. We'll just return none out of here because that will be our default case. But let's now take in our arguments. So we need all entities with children. Which is a reference to a query of anything with the component of children. We want the names. We want an entity, which will be our root entity that we pass here. And we want the name to match, which will just be a string slice. And with this, we can look for all the children of this entity and compare their name to the name to match. And if it is true, we will return it. But if we get to the end and we haven't found it, we'll return none. So to do a breadth first search, we are going to set up a data structure called vecdec. To believe it's like a double-ended queue vector. So let's make that. We'll call it q vecdec. That's a data structure that is in standard collections, but it has to be imported. So we did that automatically with the editor. We'll just make a new for now. For some reason it's not the correct highlighting. Oh, it doesn't know what type it is yet, but it will once we start pushing things. So we'll just immediately add to the queue the entity. So this will add it to the end of the queue. Still, it doesn't know. I'm confused. Oh, I didn't write, I put colon instead of equals. Let's see what happens if I do this. Yeah, it doesn't know the type, but okay, the problem was I did not write the right thing there. Okay, so now we have this vecdec with, or basically we have a queue with only the entity in the queue. So as long as there is something in this queue, we know we're not done. So we can say while let some current entity equals queue dot pop front. So we'll take the first or the oldest entity in the queue, right? Because if you push another entity onto here, then this one would be the one you get when you pop it front. So we'll take the oldest entity in the queue as long as there is one to get. If there isn't, this would return none because there's nothing in the queue. But since there is, we still have something to look at. So, or it'll be this thing. We still have something to look at in the queue. So then we're going to see what the name of that is. We have to dereference it because this is a reference. Okay. Oh, I think I wrote this wrong here. if there is a name for this, then we know it's one of our named bones, or one of our named things from whatever we're traversing here, but we will pass it the root bone. Then we want to see if this name is the name we're looking for. Since name isn't really a string, the Bevy name thing, you have to format it to a string. It does implement display though, so you can turn it into a string using this. Then we'll see if that contains our name to match. And if you wanted to explicitly match it instead of just seeing if it contained, you could just say equals. Okay. But if it, we just want to see if it contains, because later we're going to pass character armature, and there's going to also be character armature .001, so on and so forth, because they get automatically their name changed in Blender. Here you can see we have character armature 002, for example. So we want to look for it just if it has character armature. The way we'll distinguish it will be by the name of its scene and not the armature name. In any case, we would say that we found the named entity if it matches. And if it does match, then we can return it. Return some current entity, which once again, this is copy, so it will just return a copy of that entity ID. Okay, but if we didn't find it, we have to continue to search. To search, we need to find the children of this current entity, see if there's any deeper to go. So we'll look at all the entities with children, see if current entity is one of those entities. And if it is, then we'll get its children. And for every child, we'll add it to the queue to look at it later. And that's why it's breadth first. Because if you look at them immediately, it would be like when we were printing out the scene tree, that was depth first. But instead, you're pushing this to the back of the queue, and then you look at all of the topmost entities first, because you're always popping from the front of the queue, and your children are getting added to the back of the queue, so they don't get looked at until everything in the front is done. But let's say we went through everything, we pushed every child through, and we compared everything, then we didn't find it, it would just be none. Okay, so now we have a way to find uh, our root, our child that it will have a name, which will be root, which will be the most highest parent bone. So using that, we can go back and get the root bone and then use that to find all the bones. So let's do that. We'll go back to our get main skeleton bones and armature function, and we can say that the root bone is actually going to be the child with the name containing, and let's import it first of all, and let's get the fields automatically filled out for us. So we will pass it all entities with children. We'll pass it names. We have to just make a reference to that. The entity is going to be a reference to the main skeleton entity, and the name to match is root. Once again, name. Once again, this would just be the name of whatever you name your root bones in Blender, which in the asset that we downloaded was named root, but maybe you use like the Rigify add-on and maybe it names it something else. I actually don't know what they named their bone. Or you made your own skeleton and your root bone is a different name. In any case, you want your like most parented bone, or the bone that has all the children, or there's no bone above it. You want that one to be the name that you pass in here. And you would want that to be the same for all of your parts too. So this would be the root bone, and it's an option, of course, but we expect that to be a thing. So we'll expect the skeleton to have a bone called root. For some reason, I want to put quotes around that to be proper. All right, so now we have our root bone. We could collect all the bones. We also are going to want the main armature though, so we can just use the same function that we made to say we'll rename this to main skeleton armature, and we will change this to character armature. Same thing here is that it's what it's named up here, which could be different depending on how you make it in Blender. And we will expect the skeleton to have an armature. Okay, so with this, we can now collect all of our bones. And to collect all of our bones, we have to make a function called collect bones. And that is going to build our hash map, or it's going to edit our hash map and insert all of our bones into it. So we will now do that. So we'll come up here, we'll create a function, collect bones, we'll save it, we'll add it to the tree, we'll save our main function there. That's the next thing that we need to save this to. You know what I mean. All right, we will now make this function, and it's going to be pretty short. It's going to use recursion very similarly to how we did before. And we will need Bevy for this. And we'll name this collect bones. First thing we need is all entities with children, which will be a reference to our query for that, as we've been using it a lot. We need names. We need the root bone, which is what we know how to get now from the last function we made before. And we need collected, which is this is the hash map that we're going to be collecting the bones into. Which is just going to be the bones listed by their name. Okay, so the first thing we gotta do is see if there is a name for the current bone we're on. So if let name names.get dereference the root bone reference. Then we will insert it into our hash map. I think hash map needs to be imported right now though, because I'm not getting the autocomplete. Okay. And what we will insert is the name. We do have to format it because name is not a string or anything. And I bet a name actually implements hash, so we probably could even just do it like that. But I was comfortable doing it like this, so I don't know. We could always optimize this later. Okay, so we'll need to put an equal sign. So we will have this bone in the hash map, but we also want all the children of this bone. So we will see if it has children. Then we'll loop over all of its children if there are any. And we will collect bones using those children as the new root entity. And instead of root bone, we will pass the child. So that should collect all of the bones. We pass in an original root bone, which will be the one we found earlier. We'll insert it into the hash map. We'll look at all of its children. For each child, we'll do the same thing. We'll see uh, if it has a name. If it does have a name, we'll insert it. We'll look at its children and so on until there are no more children, and then it will be the base case and it will be done. So that is that. Let's use that in get main skeleton bones and armature. We'll say, I think we just have to import that, delete one of these letters so we can get the helpful autocomplete there. And instead of collected, we'll put this main bones thing, hash map that we made. I think it has to be a mutable reference though. And names has to be just a reference. And we called it name here for some reason. We'll call that names. Keeps confusing me because it is more than one. All right, so we have collected all of the bones of the main skeleton, and we need to return the armature as well. I think we already wrote this earlier just to make the error of returning the right thing go away, but now I can write the main skeleton armature. And then we should be pretty good. This was a relic of a previous iteration. I'm just going to delete that so we don't need that because we're using expect. Before I was doing the proper checking if it was none or if it was some, but we don't really need that because we are pretty sure that it will be true. Of course, that's something you could always tweak. Now let's print out these bones just so we can see. Main bones. So let's see how that looks. It looks like we haven't added this yet to added the system yet. So let's see if we can do that here. Yep, that was the problem. Oh, I needed all this. All entities with children. I guess we never added that here. All right, I must have forgot to put that in. Then let's add the assemble parts system to our main um, modular character plugin here. And we can do that probably here as well inside after spawn scene state is done. If not, I'll double check the notes, but I'm pretty sure this is fine. Okay, we have to import it manually. All right, let's see if that works. I might have put it in the wrong schedule there, but okay, it's good. So we see these are all the bones, and that matches up with all of our with all of our bones. You can see they all have the same type of names here, and now we can do the same with our part here. If we collect all of those bones and then go through each of those bones, we will parent them to these bones. So let's do that. All right, so we've got our main skeleton bones. Now we want to get the bones for our different parts and attach them. So for that, we're going to loop through all of our scenes except for the main skeleton scene and get all their bones. And so what we'll do is the following for part scene entity and part scene name in scene query. That's from up here. We will check if the name is not main skeleton.glb. So we don't want to attach the skeleton to itself. That would not make sense. Then we will get the entity commands for that entity. Sorry, no, we won't. Then we will call this function that we're going to create. Attach part to main skeleton. And we have to create this. First, why? The scene name is private, so we just fix that real quick. Okay. And this function does not exist, so we will be creating it. So we will come up to our folder, create that file, save the file. Oh, oh. I'll just paste in the function name real quick while I'm here. Save it, add it to the module tree, as we've done several times before. And in this function, we're going to require a lot of different arguments. So we're going to need the commands. We're going to need all entities with children. We are going to need the transforms, so we can set the transforms of the bones for our different parts to 0. We're going to need the names, so we can know the different names of the bones of our part. We need the part scene name, and that is just going to be to log out saying that we're attaching this part, so not strictly necessary. But we do need the part scene entity, so we can get look up, so we can get all of the children of that entity and get its bones and its armature. Then we also need the main armature entity, so we can parent our part armature entity to it. And we need the main skeleton bones, so we can parent each of our part bones to the correct main skeleton bones. That'll be a hash map, string entity. Looks like I forgot to write fn once again. Let's definitely include the Bevy prelude. Hash map as usual. Okay, so to attach our part to the main skeleton, we need to get all of the bones for our part. But let's first print out which one we're attaching. Then we will get the root bone option, and that is our find child with name containing function that we did earlier. Oops. Save it for the auto format. Put in the semicolon and save it for the auto format. Looks like it does want to go off screen, so let's just fix that. The entity is going to be the part scene entity, a reference to it, and the name to match is going to be root because that is the root bone name for all of our parts that we export from Blender. We also want the armature. It's going to be the same as this, except this will be character armature. And this is really why we're doing name containing instead of name exactly equaling, because character armature is going to be like character armature dot 001 or 2, so on and so forth for all the parts. When they get duplicated in Blender, it automatically adds that extra part at the end. So we could expect these, but let's just do it in a different style for no particular reason. So if there is some part armature, actually, I think there is a reason. Sometimes there is no armature. If you have the weapon, for example, it won't have that. And we're looping over every single scene, so we're not specifically only selecting scenes that have armatures. So let's say that if equals the part armature option. So this has an armature, then we want to get the entity commands for that so we can change its parent. And we can get the entity commands or something by calling entity on commands and then passing the entity. The entity is part armature. Then we're going to see if this has any transforms, and if it does, we're going to set them to 0. It shouldn't have any transforms, but maybe it does. So let's make sure it doesn't. Set the translation x is 0, 0. Make that for the same for y and z. And the rotation is going to be rotation equals quaternion from x, y, z, w, 0.0 for all of these. So now it should have basically no extra transforms. And then we'll set its parent. So part armature entity commands dot set parent. And this will be to the main skeleton armature, main armature entity. We have to dereference it. So like when you're changing the XYZ of, or you're changing the translation of the main, then this will follow it along. Now let's do the same for all of the bones. Well, actually, we can see what happens with just this, but we will attach the bones in a moment. So let's add this system to the rest of our, oh, let's uncomment it here, first of all. Huh? There we go. Let's make sure we are actually doing this right. Okay, the part scene name is going to need to be a reference. Oh, we have to format it. Invoke the macro correctly. CName doesn't implement display. Oh, I think I was just making a big mistake here. Yeah, okay. I mixed up part C name with the Bevy name, where you format the name. Instead, this is just the one field of the tuple struct. Okay, so that is being used. And assemble parts. Looks like it is being used, but let's just make sure that is here. Oh, it is here. All right, what happens if we run this? We're only parenting the armature. Yeah, so it changed its location. See, uh, let's see if we zoom in. There's also this unnamed entity down here, which I'm a little curious about. But in any case, you can see it moved it over there. So the actual location is over here, but the bones aren't parented yet, so we have to do that. All right, so let's do that. So let's go back to assemble parts. Let's go back to attach part to main skeleton. And with these root bones, with this root bone option, we'll get all the bones now. So let us do that after attaching the armature. Because, okay, so we are doing it like this once again in case it's like a weapon and it doesn't have a skeleton. So we want to check. We're not going to expect everything to have a skeleton. Then we will, similar to how we did it with the main skeleton, have some collection, some hash map of the bones. And we will collect bones. And instead of the collected down here, we'll say part bones. It has to be a mutable reference. Okay, so that should be good. So that will fill up this with all of our bones. And then for each of these bones, we want to set their transforms to nothing and parent them, just like we did up here. In fact, you probably could extract this into its own function, make it a little cleaner, but let's not do that right now. So let's get the entity commands for these bones so we can change their parent and, well, just so we can change their parent, I think. Nothing else. Let's find their new parent option, which will be the corresponding bone in the main skeleton, by looking at the main skeleton bones and trying to get the same name as this current part bone. So that would be this name, the current name of the part bone. See if the main skeleton bones has the same name. And if we do, if it does, we want to change it to that parent. So if there is some parent, new parent, then we will first change the transform and then set the parent. So that should be very similar to this. Let's copy it. And let's change, oh, we'll save that. Yeah, we got to change just a few things here. This would be the transforms of the part bone. And this will be entity commands, set parent. Instead of main armature entity, it will be new parent. Well, I think that's it. Let's take a look at the example here. Torso should be animating now. Yeah, it is. And since we're spawning that over there, it looks like it's a hash map, so the order in which it spawns things is different each time. That's why it spawned over here. In fact, I am gonna, now that we just spawned it one over to the side just for demonstration purposes, I will change that back to spawn it in the middle because it doesn't really matter. Like, I think that was spawned over there. I mean, actually, it does kind of matter because there's this unnamed entity thing over there. I actually don't know what that is. Um, oh, you know what? I think I do know what that is. I think it is this, which we could find out if we printed the name. Currently, though, I'm not super concerned about it because we basically accomplished our goal now. And we know how to attach different parts. So if we were to spawn a different part, we would be able to assemble the different parts and have it animating, and we could worry about that other unnamed entity at another time. So for now, let's spawn in some legs just to show that it does match up, and then we can move on to spawning the weapon. So back in Blender, we're gonna go and open the the witch blend that we downloaded in the very beginning. We can save this. So that would be witch.blend. And here you want to go up and save a copy just so you always have the original in case you make a mistake. So we'll call this witch edits, and I'll call it edits too because I already have edits one. And then we want to go and enter the layout workspace so we can see better. And here we're just going to take the legs from this one. So we're going to duplicate the entire thing by duplicating this collection. And then we'll hide the original collection, make it unselectable. And then making sure we're in object mode, we can delete the head, we can delete the torso, and we can probably delete a lot of these bones as well. So let's go into edit mode. First we have to select the skeleton. Now in edit mode, we can delete certain bones. I'm pretty sure the arms do not affect the legs at all. And we'll be kind of conservatively deleting the spine here. I'll double check which one is actually affecting it. So to check that, we'll go to pose mode, and we could wiggle this one around. Nothing's happening, so that one's probably not required. This one also doesn't seem to be affecting it at all. And let's see if we check this one. Yeah, it definitely is affecting it. Probably worth looking from the back as well. So check the middle one again here. Yeah, it's not affecting it at all. So we can delete that. We'll go back to edit mode. We'll delete both of those. And now we can select everything. Actually, we go to object mode, select everything, making sure you definitely select the root bone down there. And we'll go here, export the same way we did it before, GLTF. Do not bring the animation data. Make sure you go to only selected objects here and the mesh apply modifiers. And we could change this to which, actually we'll name it like how we've been naming them with lowercase and underscores. So which legs, export that, go over to our files, drag that to the correct folder, the assets folder, and we'll go back to our code. Then we have to load that with our asset loader. So let's look for asset loader plugin, and we just add it to the list here. So which legs.glb, save that, and if I'm not mistaken, it should attach them because everything else is pretty streamlined there. Yeah, it's all pretty automated now. And oh yeah, I did forget to change the location of it, but you can see the leg is following it, torso is following it. It looks pretty well matched up, but I think if anything, that would be an issue with the models and not the method that we're using. Or maybe the way I exported it was wrong and I should have kept some bones that I didn't. It looks like there's like a little bit of a mismatch there. But you can see it is following the animation correctly because the witch and, well, all the characters that Quaternius made for these packs, they use the same animations. So they will make sense together and they have the same bones and the same skeleton. And we could pop a head on there and we would get the same thing going on. But what I think would be interesting to do next is to attach a weapon because the weapon has no skeleton and that is going to require a modification actually to the original skeleton to equip a weapon. So we'll do that next. So to equip a weapon, first we will need to get a weapon. So let's go back to Quaternius's website. And in assets, we can search for weapon. And it should be, here it is, Modular Weapons Pack. And we will download this. and we want blends, and we'll just get the, uh, we could do sword golden, because that's one I used before, so I know how to work with it, and as far as the size and stuff. So we'll download that. Okay, it's downloaded. Go over here and find that in downloads. I will bring that over to my Blender projects folder. And we'll overwrite it. I already had one, but that's, you probably don't already have it. And then we can go open that up in Blender. And we'll save this. So we have our legs as a separate thing there in case we need to change something. And we'll open up Sword Golden. And one thing you might notice is this is an enormous sword. Our character was actually, I think, shorter than this sword. Another thing we'll notice is where the handle is where you would grab it is right in the 0, 0, 0 position of the 3D space. And that is also going to be important. So we could scale this to the appropriate size in Blender, but we can also scale it in Bevy. And since this is really a tutorial more about Bevy, that's what we're going to do. So all we want to do is just export this. So we will export GLTF, and I don't think there is any animation in this sword, but I'll uncheck it just in case. And I don't need to check anything. Actually, let's make sure. Is this mirrored? I would think it's probably not mirrored, but I'll apply modifiers anyway. And we're just going to call this sword in lowercase because we're only going to use one sword. Go back over to downloads. Did I not export? Oh, not downloads. It would export to wherever you export. I'd export to the Blender project. Move it over to the assets folder. And then in our asset loader, we want to load that. So sword.glb. Can save that. Now, if we were to run it, our sword should just appear in space. It would probably be really big. Yep, there it is. Very nice. And they're all spaced out extra, like by 2 each time. So we should probably change that. Let's go to the scene spawning, spawn scenes, and we'll just get rid of that and get rid of that and change this back to 0 to 0. So now everything will spawn on top of each other. And we want to attach this sword to the hand of our character. And an easy way that I found to do that is to create a special bone in the skeleton that is kind of the handle bone or the place where you will attach the sword to. So let's go back to Blender. We will open, we can open recent. We'll go to sci-fi edits. And I suppose we can save our sword there. I don't know what we really changed. So here we were working on our original character here. We're going to hide the torso. We're going to unhide the original. Actually, not that. We want the main. Actually, yes, this. We want this. Okay. I was going to say we're going to look at the main skeleton because what we're going to do is make a different main skeleton. And the reason is we need to see the mesh handle so we know exactly where to place the bone. So one thing you can do is click on the bones to be able to see them through the mesh. To do that, we'll come over here to Data, Viewport Display, and then check off in front. So now we can see the bones even though they're inside the mesh. Let's go to Edit Mode, and we want to put the sword in this hand. So we'll move over there, and we want to create a bone that is kind of perpendicular to this area, pointing just about there along this way. To do that, we're going to click on this wrist bone. We'll press E to extrude, and we'll bring this bone in the x-axis only, so we'll constrain it to the x, and maybe about this far out. Then E to extrude in the y-axis only, bring it about there. And I think that's a little too far back, so I'll click on it, G to grab, and we want x-axis, move it a little bit over there. Oops, I canceled it. A little bit right about there. Let's just rotate around and see. Yeah, maybe a little bit further. And we also want to bring it down. So G and then Z. Bring it down right about there. Let's rotate it around. And that looks just about where a sword handle or any type of thing you would hold would go. And then we actually don't need this bone because I just used that bone to kind of like come over here and then extrude another bone. So we can delete that bone and then make sure this bone is a parent of this bone. So we'll select that bone first, then shift this bone. I believe it is just P. No, Control P. You know what? I think it's already parented. Control P was the right thing though, because you can say keep offset or connected. So it's already keep offset, I believe. We can double check that by clicking on this. Let's rename it with F2 to handle.r, or maybe equipment handle. And then let's look in the tree here to make sure it's properly parented. This would be probably hips next. Yeah. Gotta scroll over. What shoulder are we at? L? Nope. We want R. Okay. Yes, it is properly parented to the wrist there. So it will be following the position of the wrist, but it will keep this sort of perpendicular orientation to the wrist. We can also double check that by moving this around. And if we go to pose mode and grab onto this, then we should be able to see our handle bone. Yeah, it's right there. It is getting moved around properly with the other bones as we move them around. Okay, so we've added that handle bone. Now we want to export the skeleton again. So just like originally we did that, we will duplicate this collection. We will hide the main collection. We will rename this to main skeleton with handle. Maybe equipment handle, because handle is a word that gets used for a lot of stuff. Especially confusing because Bevy uses handle. And then we need to, in object mode, delete everything that is not the skeleton. This is just going to be the same as before, how we exported the skeleton. Select the entire skeleton, export GLTF. Remember, we do want the animations because this is the skeleton, and the skeleton is, we're using that to also store the animations in the GLTF. Only we want selected objects, and I do not think any modifiers really matter, but actually these aren't meshes, so it probably doesn't matter at all, but I will check it anyway. And let's name this just main skeleton because we're going to overwrite our other skeleton. The black square means it was exporting. Now it's done. Back over here, bring that over. We can overwrite that. Now we can parent the sword to the equipment handle bone. So we'll come back over to the code and let's go to the assemble parts. And here, where we are attaching all the parts to the skeleton, we actually want to do a different thing if it is the sword. So if part scene name dot zero equals sword dot glb, and then we'll put it else here. Then we want to attach the sword just to that handle bone. So we're going to get the entity commands to do that to set its parent. And then we're going to see if there is a handle bone in the skeleton, which there should be. I think that's what I named it. And then we will just set the parent to that. All right, I called it sword entity commands. Now let's see if that worked. It looks like it is working, and our character is obviously super strong because they're able to swing a huge sword like this. But we can't really tell if it's lined up correctly because the size is too big, so we want to scale this down when we are spawning it or after we're spawning it. I'll just scale it down right after it gets spawned, so let's go do that. So let's go to spawn scenes, and where we are spawning the scenes, we are going to change the transform if it is the sword. So instead of just making it transform for all the scenes, let's set up this. So we just moved this transform up to here, and now it's mutable. So we can say if name is sword.glb, then we'll change the transform scale, just the scale. And it's another splat type, and we're just gonna make it 1/100th size of itself. Now, that size worked pretty well for me before with this same model, so hopefully it does look good. It looks like I've made an error because the sword is either very tiny or completely disappeared. So let me get right back to you about that. Pretty sure I meant to make it 1/10 of the size. That makes a lot more sense. Let's see. Yep, there it is. So that looks to be pretty well in their hand. I think it will be easier to check if we pause the animations. So we'll pause the animation, check the position a little bit better. To do that, we can go to our run animations and just not run it. So let's see how lined up we are. I would say it's I always mix up the Blender controls with this camera. It looks like it is kind of lined up, but to change that, you could just change how the bone was in Blender. And whatever angle you have it on, it will be lined up like that. But you can see it did work like all right. And obviously you would fine tune that specifically for your different requirements. So that is basically it. We've created a modular character, and yeah, this took me quite a while to figure out, many weeks of researching and experimenting. Had to learn Blender, so I was not like I knew a lot about this when I started. So the 2 weeks of solid focus plus all the extra time, like I didn't really count it, but I've been thinking about this since November of last year, and on and off. But yeah, it's kind of pretty cool. I think there would be other ways I'd rather be able to do this, like instead of having to have all these like duplicate skeleton bones, maybe there would be a way to take the skinned meshes and delete all of their bones, but then make their bones be the same as the skeleton or something like that. But I've tried for a while to do it that way first, and then I got this idea, and this actually worked a lot faster. So, assuming there's no great performance cost or any other reason you wouldn't do it this way, I think I will be doing this for my project, and hopefully it could help you with your project. And if you figure out a better way to do it or any ways to optimize, I would love to hear about it in the comments. So this just about wraps up the video on modular characters in the Bevy game engine. Something we didn't cover is how you would remove a part after you attached it, and for that you would have to probably keep track of all of the bones after you change their parents, because normally when you despawn something, you can find the parent of a scene and then despawn recursive is a method on that you can call to get rid of it and all of its children. But since we changed the parents of all of his children, you wouldn't be able to do that anymore, I suspect. So we'd have to come up with our own system for how to do that. And I think if you're able to follow along with this video, you could probably figure out how to do that with not too much problems. So yeah, that brings us to the end of the video. And, there's some mysteries left unsolved, but I would say that I hope this gets you off to a good start. So I want to thank you for joining me on this journey, and this has been Mike Silverman from the Snowden YouTube channel. Hope to see you next time. Goodbye.